Okay, so in this second hour, we are going to talk about the algorithm of this k-means, the steps of this k-means algorithm. So we want to implement this algorithm into Python and try to do that by ourselves. So we need to know how does it works. So in order to do so, we have to understand what is the input and what are the output. So for input, you have to supply the data, and the data is an n by d array. And you don't have to supply what is y. This is an unsupervised learning. So you have the data, it will try to generate some of the label. But in this algorithm, you have to supply what is k, and k is number of clusters. Okay. So you have to tell the algorithm how many clusters that you want, and you have to give the data. On the other side, the output is the labels, right? And somehow we want the label, and also in my design, I will also want the centers. So this y new is the new labels. It is an n array, and it records the labels. And the labels is between 0 to k minus 1. Each data will have a label. But this k tells that how many kinds of labels we have. Okay, we have k types of labels. And the centers is the same as model the cluster center. Okay, and center is k by d array. And in there, each row is equal to each center. All right, and with this in mind, we can run the steps. And the nice thing about the k-means is the steps are actually quite easy. There are basically just 2 steps, and you have to run that several times. So the first one, just randomly pick some centers. So each cluster, we have k clusters, and each cluster has a center. So let's just randomly pick some as the cluster center. And secondly, now we have the center. And obviously these centers is not going to be optimal. It's not going to be good. So we are going to relabel all the points. So we're going to label the data points. And each xi will be labeled by j. And what is this j? This j is the index of the closed center. So if mu j is the closed center for xi, then we are going to label xi by j. And here is an illustration. Okay, xi, and you got mu0 here, mu1 here, and several points. And somehow there is a particular mu_j that is closest to xi. And in this case, we are going to label xi by j. Okay, so this is what I meant. Several centers. You have k centers. All the centers may be far away from xi, and this one is the closest to xi. So we are going to label xi by mu_j. Once that is done, the third step is try to ignore all the centers and calculate the new center. So with the new labels, we can say cluster J are all the points with label J. Okay. And after that, we can say mu_j is equal to the center of cluster J. So here is how it might look like. Okay, so at the beginning, we randomly pick three clusters, three centers, and it might look like this. Okay, maybe we're unlucky that all the centers are here. And the next step, it is the same data set. Okay, now we have three centers. Let's call that as mu0, mu1, and mu2. Okay, but you will see that, okay, this guy is closest to mu2. All the points are closest to mu2 except for this one. So we're going to label all the points by its closest center. This one is closest to 0. This one is closest to 1. This one is closest to 2. But if you look at this guy, it is closest to 2, 2, 2. And after that, you will see that now this part is one cluster, right? So this cluster, you can calculate a new mu2. And for this one, you will calculate the new cluster, but in this case, it is going to be the same. And so this is step 2, and this is step 3. And you can tell that after step 3, the cluster will move a little bit. You'll move to here, and afterward, we are going to repeat this process again and again. Now we have new clusters, centers, and all these points are going to be labeled by 2, and by maybe this is going to be labeled by 0, and 1 is still here. So we are going to label the whole points again, and after that, and calculate the center again. So the last step is try to repeat step 2 and 3 several times until you want to stop, or until the labels never changes. So according to the theory, you see this is one type of label, and after step 3 and come back to step 2, the label will be changed again. But according to theory, if you run this several times, several rounds, the label will converge, which means that it will goes to a certain stage such that the label, after going to step 3 and coming back to step 2, it is not changed again. So you can try to detect this behavior. If the label does not change for one step, then it is not going to change forever, right? So you can stop at that point. All right, so that's the philosophy or the steps of the algorithm, and pretty much it is following just 2 steps. One is labeling the data, the other is calculated the new centers and come back with the labeling and do the center, label, center, label, center, and do that several times, and you will come out with a good behavior. So that's an interesting thing, because k-means it's just 2 steps, but somehow it has a solid theoretical background that it will generate a small inertia for your data. Okay. So again, I will pause for a while, and then I will move on to how to really write down these codes. I will give you some lines and tell you how to do so. Okay, so let's revisit all the steps, because we are going to do the coding. All right, the first step is try to randomly pick some mu. And to do this, you can just pick some data point as the center. Okay, so this one, try to randomly pick that. And second step and the third step is the label and center, and finding the center. So let's try to do that. Okay, so recall that the step 1 is randomly pick the data. And I realized that my writing is terrible, so I'm going to type and then come back to here. Okay. So the first step is we have some x, and then we want to pick some points as the centers. So let's say x is given, and I'm going to do indices. Indices means that what are the indices of the data. I'm going to use the random function and use the choice function. So you can see what is choice. What does choice mean? Let me show that to you. Choice means that you can pick something from here, say 135, and then you want to pick. You want to pick 2 things. Then you will randomly pick 2 things for you. Okay? So sounds reasonable. Okay? And now what I'm going to do is try to pick something from a range n. And the n is the size of x. And of course, you have to adjust the things by yourself. And I'm going to pick k centers. So that's what I'm going to do. Somehow I do replace equal to false, because I don't want to change the the data. I guess this one is optional, so it is up to you. So I do ind equal to this new things, and then say centers is equal to x, and select inds and select all. So the second one is a bit interesting. So let me tell you what's going on. X is m by d, right? And we have inds. What is that? It is just one-dimensional array with k numbers. And after taking that, you pick k centers and you pick all the rows. Okay, so you pick k centers by these indices, and then pick all the columns. So it will becomes like this. Okay, so let me move on to copy that to the other part. And by the way, because of the software, the recording is not doing the record. I mean, the recording only record this blackboard. It does not record what I wrote there, but I copy to here so that you can see. So what I mean is, recording does not record what I did here, but you can see everything here. Okay, so this is the first step. You are able to calculate, randomly pick some centers. All right, and then we do the step 2. Step 2, we are going to relabel everything. And this one is not too bad because step 1 is randomly pick, and step 2 is to randomly pick some. Step 2 is to label the xi by j. Okay, and j is the index of the closest center. So we have to calculate the distance. So let me write it down and then come back to here. So we can use the distance function that we use in MDS. There is a dist matrix function. If not, just go back to the MDS. You can calculate the distance between centers and x. And then distance, you can do y new. This one is not too bad. mp.argmin. And say x is equal to 1. Okay, so let me copy this to the other place and write some explanation here. Okay, so now we have this code, and for this dist mtx function, just go back to see the MDS, the handout of MDS. Now, this will generate an array, and the array is m by k. Okay, m by k. So what does that mean? If you have an entry here, it means it is the distance between xi to to mu j, the distance between xi to mu j. So if you focus on a row, this row will tells you when I have xi and what is the distance between xi to mu0, mu1, mu2 up to mu k minus 1. So this row records the distance from xi to each center. And now among these, we are going to pick the one with the shortest center. So I'm going to do the min function. But what I want is the index. I don't want what is the value of the distance. I want the index. Okay, so I'm going to do the argmin along the axis 1. So for each row, it is going to generate one index such that the minimum value happens on the index, and that is y new. So later on, you can try that by yourself and try to digest these codes. The step 3 says that we are going to calculate the center. Okay, so you can do it by your own way, and in this case, I'm going to do it by for loop. You can do that by broadcasting, but it is going to be hard to understand. And meanwhile, just maybe it is not necessary to do so. So I'm going to do the for loop. For each cluster, we have k clusters, right? And for each cluster, well, I'm going to find out what are the data points. So mask is equal to y new equal to I. Okay, so this will tells you true and false depends on whether it belongs to the ith cluster or not. Let me change that to j because cluster are using j. And later on, I'm going to take x and mask. So X mask will take all the data points in the jth cluster, and then I can take the mean. Okay, so this is the new center for cluster J. So centers, the jth centers of that should be updated by this new value. So again, let me copy that to the other part. Okay, so I think this one is self-explanatory. Take all the cluster, and then the jth center is going to be this new center. So this one is calculating the new centers. So step 4, you have to do it by yourself. Try to pack step 2 and step 3 by a while loop. And you have to think about how to make it stop. Okay, either you set up 1,000 steps and then stop. That's okay. But you can also check, keep recording what is y new. And once the y new is the same as the previous step, then you can stop. So that's what I want to say for this second hour.